Hi everyone. So if you watched my previous videos, we talked about constructing Punnett squares that had to deal with autosomal traits. Now what we're going to look at is what happens when you have a sex-linked trait. So when we talk about a sex-linked trait, this means it falls on the X chromosomes or the Y chromosomes. For females, we have two X's. So they're long and they actually have lots of different genes on them. For males, they only have one X, and then they also have a Y chromosome. Now, the Y chromosome is actually quite short and doesn't carry a lot of genes. What will happen is mom can only give an X chromosome. And so, because of that, dad actually is the one that determines the sex. He can give an X chromosome or he can give a Y chromosome. And that's what's going to make differences between males and females. But what happens when we talk about X-linked disorders or X-linked traits? They're not on those autosomal chromosomes. They only fall on either the X or the Y. So let me give you an example here. We're going to talk about color blindness. Color blindness is an X-linked trait. So what has to happen is in order for a female to have color blindness, both of her X chromosomes have to be affected. But for a male to have color blindness, because he only has one X, the probability goes up quite a bit that he could potentially be colorblind. Now, females can be carriers, which means that they have one affected chromosome, but they don't actually have color blindness. But if you see a male like this, that means that they don't have that trait, therefore they don't have color blindness. So let's construct a Punnett square for color blindness where mom is a carrier and dad is, we're going to say normal and doesn't have color blindness. So if mom's a carrier, she looks like this. If dad is considered normal, quote unquote normal, then he's going to look like this. Let's see what the chances are that they're going to have offspring, whether they be male or female, that will be colorblind. So I'm going to put mom at the top. I'm going to put dad off to the side. So with the Punnett square, this is called a monohybrid cross. We're only looking at one particular gene, and we're trying to see what the potential phenotypes can be. Remember, the genotypes look like this. They're what alleles that person carries. The phenotype is the physical expression that we're going to see. So from this guy here, or this person, this is a female, and she is a carrier, but she doesn't actually have color blindness. Now, if we go to this individual, the chances are that this would be a female that's not affected at all. She would be considered normal or healthy and not a carrier. But now if we look here, this would be a male that does have color blindness. And then the next individual would be an XY, so that's a male that doesn't have color blindness. So every single time mom and dad go to reproduce, there is a 25% chance of having a male with color blindness. There's no chance of having a female with color blindness, but there is a chance for the male with color blindness. Now, color blindness is not necessarily a huge deal. Actually, my son is colorblind, and he has an issue with red-green. So typically it's not problems with bold colors, like if they're all just one color, but if there's patterns, he can't see them very well. However, you can think about someone that has hemophilia. If you hear the term hemophilia, this is an individual that's missing specific clotting factors, whether it be factor 8, factor 9, and because of that, they don't properly clot their blood. They don't properly have this fibrin clot formation. And it's not the fact that they can't clot, but it takes a really long time for it to occur. So for hemophilia, it's also an X-linked trait. So again, for females, in order for them to have hemophilia, both of their X's have to be affected. But for males, they only have that one X. So the chances are much greater that boys or males will be affected with these traits than females. And if you look at pedigrees and if you look at different kind of historical records, males typically were affected with lots of different traits, especially for hemophilia. Back in the day, hemophilia was sort of a death sentence because they didn't have a way to help these individuals if they were cut, if they fell, if they were in an accident. Now, due to science and research, they have come up with synthetic clotting factors, and that person can live a relatively normal life. But let me give you this example here. The royal family are well known to be interrelated, and this is true of the Romanov line of Imperial Russia. The close relations led to the presence of X-linked recessive disorders like hemophilia. We have the Emperor Nicholas, who is a healthy individual. So he looks like this. And his wife also does not have hemophilia. So if she doesn't have it, she either looks like this or she looks like this. But here's the little piece. His son, Alexei, did develop the disease. So their boy does have hemophilia. So we know the emperor has XY. They say that he's a healthy individual. They say his wife doesn't have hemophilia, but they don't say that she's not a carrier. It doesn't say that she doesn't have any of the traits. So if we were to conduct a Punnett square, let me show you both options. If mom was healthy and dad was healthy and they didn't have those traits, there would be no chance that any of their children would have hemophilia. But here's where things change just slightly. If mom was a carrier, now what can happen here is that child would be a carrier, and now this boy would have hemophilia. So now already looking at it, there's a 50-50 chance of having a male or female, but now you've increased that chance that that boy is going to have hemophilia. And again, if we start to look at pedigrees and we start looking at the historical records, boys were very much affected with hemophilia. So I hope this makes sense and kind of brings everything together. I hope you're having a wonderful day, and I'll see you again soon. Bye.